Hello everyone. This video is on the Knewton Alta assignment for section 2.7 part 1 called Inequalities, the Number Line, and Interval Notation. Alright, so in this video I'm going to be going over a preview version of this assignment, so please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same, the structure is similar, so I'm hoping that watching me do these here help you in some way when you're working on the assignment on your own. Alright, so the assignment page, you should be seeing the title, the mastery bar telling you how far along you've gotten, all the objectives. Looks like there are two objectives in this assignment. Under the current objective, right, there's a question related to that objective. And at the bottom of every question, you should have a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button, right? That's for instructors only. But you will have the more instruction button, which if you're struggling with a topic or a question, you can click on this and it'll take you to a page with some further reading or videos to watch and study, and then you'll be given questions related to that instruction, and you can work through the assignment by completing those questions as well. Alright, so the first objective I'm looking at is express an inequality using interval notation. Alright, so I'm going to write this inequality here and talk about, graphing an inequality, which just means draw a picture of all the solutions, all the numbers that'll make it true. And then once we look at a graph, I feel making a graph first makes writing things in interval notation much easier. This is my personal opinion. Alright, so this inequality we're given is, m is less than 29. Alright, so first I'll graph the solutions. Now remember, anytime you hear the word graph, that just means draw a picture representing the solutions, or a picture of the solutions to an equation or an inequality. So here we have just a single variable, m, so I should draw a picture on a single number line. So what I have here is called, a number line, or the real number line. And I hope you know how the number line's set up. Got 0 somewhere, usually it's put in the middle. This point represents the number 0. And then as you go from left to right, the values increase, right? So you have 0, then 1, 2, 3, 4, 5, and so on. As you go to the left from 0, you got -1, -2, -3, and so on. And even, so far I've just been listing integers. Every number in between is also there. You have a half, you have, pi. Remember, pi is about 3.14. That's between 3 and 4. There's the number pi. Negative square root of 2. Every number, every real number, right? Maybe eventually you'll talk about imaginary numbers, but I don't think that's going to be really brought up all that much in this course, this beginning algebra. But every number has a place on the line. And like I said, it goes low to high. If you go left to right, you're going low to high. So, -2 would be considered smaller than -1. -1 is considered smaller than 0, and so on, right? So numbers to the left are smaller than numbers to the right. And we're asked to, say, hey, what numbers can I replace m with to make this true? M is less than, m is smaller than 29. So where would 29 be? Well, based on my drawing here, 29 will be somewhere over here. And then all the numbers less than 29, all the numbers smaller than 29 that would satisfy this inequality are to the left. Forever. All right, I'll put a little arrow on the end of that. But all these numbers here, all right, the numbers, 28, 27, 26, 0, -1, negative a million. Put a little arrowhead on the end, right? Again, all the numbers to the left of 29 are less than 29. If I plugged in 4 for m, or 0 for m, or -3 for m, this would be a true statement. All right, you're trying to make this statement true. Find solutions. Now, what about 29 itself, right? Notice I talked about all the numbers to the left of 29. Is 29 less than 29? If I replace m with 29, is this true? No. Okay. 29 is not less than. 29 is not smaller than 29. 29 is equal to 29. So the way we're going to indicate that is above 29, I'm going to put an open point or a parenthesis. So you're going to see that in graphs, that an open point or some sort of parenthesis, right? A left parenthesis, I would put a right parenthesis on it because it's opening, all the numbers that are smaller than it are to the left. But if you see stuff like that, an open point or some sort of parentheses, that means that the number is not a solution. Okay, so 29 is not a solution, got an open point above it, but every number to the left of 29 has a closed point, is filled in, solid, and those are solutions. And you'll see other graphs where they put a solid point above a number or a bracket, like a rectangular bracket, either opening to the right or opening to the left like this, one of these. If you see stuff like this in a graph above a number, that means that that number is a solution. It does make the statement true. And these parentheses and rectangular brackets that indicate if a number is not a solution or if a number is a solution, these show up in this thing called interval notation. Now, interval notation, again, it's just another way to express the solutions of an inequality. It's just another way to express a set of numbers on the number line. You always write an interval from low to high, from left to right. You always write an interval from low to high. Or in this case, again, from left to right. So how intervals look. All right, so here's the interval notation for the solutions of this inequality, for this set of numbers that I have in this picture. You have this one big piece of solutions here, this big orange piece that I have. Now, you start off with a left end. You go low to high. You have a left end, comma, right end. Now notice, I drew this here. There's an arrow on the left. There is no left end. It goes to the left forever. All the numbers to the left of 29 forever are solutions. So to indicate that there's no left end, I would say that the left end is at negative infinity. So if there's no left end, you're going to indicate that with negative infinity. If the arrow goes to the right, if there was no right end, you'd indicate the right end with positive infinity. All right, just be aware of that. So there's no left end, so I'll put negative infinity for the left end. And like I said, in these intervals, there's a left end. And then this piece of the solutions, all this solution set here, the right end is at the number 29. Right, it stops at the number 29. Right, so I have negative infinity, again, to indicate that there's no left end, comma, and then the positive 29 is the right end, right? The right end of this interval, the right end of this solution set. And then you cap off these numbers with either parentheses or brackets. And like I said earlier, parentheses are used if the number is not a solution, and brackets are used if the number is a solution. Now, infinity, negative infinity, those aren't numbers. They're ideas. You can't plug in infinity. You can't plug in negative infinity for a variable. So you always have parentheses capping infinity or negative infinity. The parentheses will indicate that negative infinity is not a solution, right? Because it's not a number. And then you do the same to the right end, cap off the right end with either a right parenthesis or a right bracket. It all depends on if that right end number is a solution or not. Well, we said earlier 29 is not a solution, right? I have this open point here, so I'm going to put a parenthesis symbol on the 29. Right? And this is what they're asking us for. The picture of the solutions to this inequality, all the numbers less than 29. This is the interval describing those numbers. All the numbers from negative infinity to the left forever up until 29. Right? And you hopefully see that in the picture, but not including 29, right? Parentheses on the 29. And as I said, always have parentheses on infinities. Right? Infinities are not numbers. All right, and we'll see other examples, I'm sure, as we go through this assignment, but let me punch this in. So left parenthesis, then negative infinity. Now you should see the infinity symbol somewhere here. Right, there it is. And then comma, and then the right end was at 29, and then close parentheses. Right, there was another parenthesis because 29 was not a solution. All right, then after you submit an answer, it'll tell you if you're right or wrong, which looks like we were here. And then give you some sort of answer explanation. Please read through the answer explanations just to make sure you understand why something was correct or incorrect, and hopefully you can learn from your mistakes for future questions. Alright, so moving on. Alright, so it's sticking with this objective, express an inequality using interval notation. Alright, so once again, I'll draw a picture first. Alright, I like drawing a picture of the solutions to an inequality on a number line, and then I find that picture makes it easier to write out the interval. Alright, so this inequality, we have the variable b. Here it is b is less than or equal to. Right, you got the or equal to now in there. Negative 1.4. Right, negative 1.4. So again, here's a number line. Now this represents possible values of b this time. Right, so I'll put the letter b over here maybe. And again, you don't have to do this every single time, but I'm just going to put some numbers in here to remind you of how the number line is structured. You got 0 somewhere, and then +1, +2, +3 going to the right, and -1, -2, -3, going to the left. And remember, numbers to the left are considered smaller than numbers to the right. And then -1.4, that'd be -1, and then there's -1.5. -1.4 would be a little bit to the right of that. There's -1.4, let's say. And so -1.4 would be considered bigger than -1.5, right? Because it's to the right of -1.5. But anyway, so what we're looking for are again numbers that make this true when I replace b with them. So any number less than -1.4 is a solution. So those are these numbers here, right? All the numbers to the left of -1.4, forever. Little arrowhead on the end there. So, -1.5, -2, -3, -1,000,000. Those are all less than -1.4. And then what about -1.4 itself? Is -1.4 less than or equal to -1.4? And the answer this time is yes, because of the or equal to part, right? Because they are equal, it satisfies this inequality. So I put a closed point, right, a solid point above -1.4. And there's a picture of all the solutions of this inequality, right? A picture of all the numbers I can replace b with and make this a true statement. All right, and now for the interval. Again, always going low to high, left to right in this case. Well, there is no left end again, right? The lowest number, there is no lowest solution. It's going to the left forever. So once again, I indicate that with -infinity, comma. And then the right end of this picture of solutions is at -1.4. Now remember, then you cap these off with either parentheses or brackets. Now -infinity is not a number, so it can't be a solution. Always parentheses on the infinities. But -1.4, we said, is a solution. It does satisfy this, so I put a rectangular bracket on this. Now try not to rush these, because very often people will rush trying to draw their brackets, and then they make them look too curvy and make them look like parentheses when they should be a bracket. And there you go. This is called the interval. It describes the set of solutions. It's all the numbers less than -1.4 and including -1.4, right? That's what the bracket's there for. And that's what we're asked to enter, right? The interval notation. All right, so back here, left parentheses, -infinity because there was no left end, comma, then the right end of that picture was at -1.4, and then a rectangular bracket, right? Just a right bracket, which you can type in from your keyboard. All right. Great. All right, next question. All right, so now so I've basically been doing this. I've already been showing you graphing. So graph an inequality on the number line. Pretty simple stuff. So far it's already, every single one of these has had the variable is less than or is less than or equal to. Just remember, if the symbol is flipped around, it's is greater than or is greater than or equal to, right? Number is bigger than the number on the right side. All right, so very simple. These should be pretty simple. Making a graph. We have x is less than 1.5. And here's a number line. This time it's representing possible values of, the variable is x this time. And again, you don't have to do this each time, but I'm going to for this video. Just here's 0, and then you got 1, 2, 3, and so on to the right, and -1, -2, -3, and so on to the left. Now 1.5, positive 1.5 would be halfway between 1 and 2 here. Right, there's 1.5 on the number line. And our solutions are the numbers that replace x, and x needs to be less than 1.5 or smaller than 1.5. Remember, the numbers that are smaller are to the left. So again, we have, a little arrow to the left here forever. 1.4 is a solution, 1 is a solution, 0, -1 million, -pi, -square root of 3, any number to the left of 1.5 on the number line is a solution to this inequality, but not 1.5 itself. So above 1.5, I put this open point, this hole, because 1.5 is not less than 1.5. It's equal to 1.5, not smaller. So I've got an open point there. And then I might as well do interval notation. I know they didn't ask for it, but just to practice it some more. So again, this here, the picture of the solutions, there is no left end. So again, I put -infinity, comma. The right end of the solution set is at 1.5. And I'd have parentheses on both of these, right? Because neither one of those ends is actually a solution. All right, but they just want the graph, though. And it is multiple choice. You see they have parentheses and brackets. So instead of an open point, they'll have parentheses. And instead of a closed point, they'll have brackets. Just remember, parentheses means it's not a solution. Brackets means it is a solution. So it's this first option here. See the parenthesis at 1.5, so 1.5 is not a solution, and then all the numbers to the left are indicated in blue, or whatever color you see. So this is a picture of the solutions, and that's the only one that actually works. Okay. Now me personally, I like having open points and closed points, but like I said, some people graph with parentheses and brackets right on the graph like this. Alright, so here, another graph. X is greater than or equal to 5/3. So once again, I'll draw this out. And I'll even write the interval notation, right, just to keep practicing that. No harm in it. So the inequality is x has to be, some number greater than or equal, right, greater than or equal to 5/3, right, which is 1 2/3. Okay, so here is a number line representing possible values of x this time again. Again, I'll just mark off some integers, and then -1, -2, -3, and so on. Now 5/3 is 1 2/3, so it's closer to 2 than it is to 1, but there it is, right there's 5/3. And now this time though, x is a number greater than 5/3. X needs to be bigger than 5/3. Remember, numbers bigger than a number are to the right of it. So, again, a little arrow. But all these numbers, 2, 2.5, 3, pi, 1,000,000, right? All these numbers, if you plug them in for x, would make this true. And then 5/3 itself also works because of the equal to part. 5/3 is equal to 5/3. Right? So that works as well. So I'm putting a closed point or a bracket. Right? They would also put a bracket that opens to the right. So there's a picture of the solutions. And then once again, I know they're not asking for it, but I'll do it anyway. Here's the interval notation for this solution set. Now this time the left end is at 5/3, comma, and then there is no right end, right? There is no largest solution. So I'm going to just put infinity for the right end to indicate that there is no right end, right? It goes to the right forever. A bracket, one of these rectangular brackets on the 5/3, right? Because 5/3 is a solution. And then, like I said before, infinity is not a number, so you always have parentheses on infinity. So if you were writing interval notation, this is what that would look like, the description of these numbers greater than or equal to 5/3, but they only want the graph. And I think, they're going to have a bracket on the 5/3 instead of a closed point, but, let's look at the pictures. So it's this last one here, right, with a bracket on 5/3 indicating that it is a solution, and all the numbers, greater than 5/3 to the right of 5/3 are solutions as well. Okay. All right, so one more graph. Now this is x is less than 0. So I'm not going to write this one out this time. I'm just going to say, hey, this is all the numbers left of 0 and not including 0. Right? 0 is not less than 0. So you have a parenthesis on 0, and all the numbers to the left of it are solutions. So that's this first option. Pretty simple. And then one more graph. X is greater than or equal to -1. So you're going to have a bracket on -1, right? Anytime you see the equal symbol, the half equals, greater than or equal to, less than or equal to, you're going to have a bracket instead of a parenthesis. You're going to have a closed point instead of an open point. So you have a bracket on -1, and then all the solutions are, -1 and any number greater than -1. So all the numbers to the right of -1 with a bracket on -1. That's this last graph here. All right, so those should be simple enough. All right, then back to interval notation. So again, greater than or equal to -8. So that's from -8 to infinity, including -8. So -8, comma, infinity, with a bracket on -8. Right, this is the numbers greater than -8. Right, so from -8 to infinity, or equal to -8. That's why I've got the bracket on -8. And again, always parentheses on your infinities. Right, so I'm just going to talk these last couple ones out. You should be able to draw a picture yourself. All right, and then the last, based on my progress, I should have just one more of these. Yeah, and then A is greater than -3.3. Notice it's just greater than, not greater than or equal to. So -3.3 is not a solution. I'm going to have a parenthesis on it, right? And it's greater than, so we're going from -3. First parentheses, -3.3, comma, and then to infinity, right? Positive infinity, and then parentheses again on infinity. This interval is the interval for all the numbers, greater than -3.3, right? -3.3 to infinity, but not equal to -3.3. Thus the parentheses. And after you write a few of those out and get some practice in, see some other examples, these should be that quick. And that should be it for this preview version of this assignment. Now, as I said at the top of the video, the questions I saw here may not be the same questions that you see when you work on the assignment yourself, but the objectives are the same and the structure is similar. So it should, I'm hoping, that watching me do some of these here help you in some way when you work on the assignment on your own. And thank you very much for watching.